Hey there, Advanced Math. Gonna continue our talk about turning fractions into decimals today. We're gonna talk about two different types of decimals. So go ahead and make that the title on your next math notebook page. And when you are all set with that, close it up. Give me your total concentration until we get to the we-dos. All right, so real fast. Quick things to review. So changing fractions to decimals. Did this in our last lesson. If instead of 6 4/7 I want to write that as 6 and a decimal, all I have to do to convert the 4/7 to a decimal is think of it as a division problem, rewrite it with division at 4 divided by 7, and go put that decimal here. Today you're going to see me use this high precision calculator. It goes out like 100 digits instead of stopping after 6 or 7. And it's going to help me out a little bit with some things. So 4/7 is that. If you'll notice, it is a repeating pattern, right? It's this 5 7 1 4 2 8 5 7 1 4 2 8 5 7 1 4 2 8. So 5 7 1 4 2 8, and all that repeated over and over. I think we've talked a little about that symbol, and if we haven't, we're going to today. So this is the decimal for this fraction. And you can see this is a little more than 6 1/2. Little more than 6 1/2. Looks about right. The other thing we'd have done is we've talked about rational numbers. And rational numbers, if you'll recall, are any number that can be written as a fraction. So obvious ones include ones that are already fractions. That's a rational number. Mixed numbers can be written as fractions, so they are rational numbers. Whole numbers, I guess that's a negative number. Integers, they can be written as fractions, so they are rational numbers. And then we even talked about decimals, like that. That can be written as a fraction too. 25/100ths, which would be what, 625 100. So anything that can possibly be written as a fraction is a rational number. Okay, so today I want to press a new point home that goes with changing fractions to decimals. So here's the first one. There's two sides to this. One, all rational numbers can be represented as either terminating decimals or repeating decimals. So when you change a fractional number to a decimal, which is what we're going to do here, there's two different things that can happen. So the first one is ones like this. This, you probably already know the decimal for 4 1/2 because you've gotten used to it over the year. But if I go to my calculator, clear it out, do 1 divided by 2, I'm going to get a 5/10 fraction. So 4 1/2 is the same as 4 5/10. We call this a terminating decimal. The word terminating means end. So this decimal ends. It's one digit and then it's over. It stops going. This one's going to be the same. 6 5/8. If I go to my calculator and do 5/8, the decimal for that is 625 thousandths. Sorry. 625 thousandths. And again, that decimal ends. It doesn't keep going. It has a finishing digit. That's called a terminating decimal. It ends. Last but not least, 17/16. Also a terminating decimal, I believe. And there it is, 1.0625, or 1 625 10,000ths. There it is. So all those decimals end, you'll notice. Those are called terminating decimals. On the other hand, ones like this, 1/3, when I go calculate as a decimal, it's something that repeats over and over and over and over and over again. third you've probably seen, it's a 3 over and over and over and over again. And it doesn't actually stop at here. It would keep going. There's just not enough stuff, not enough room in the calculator for it. So we write that like this, 5 3/10 repeating. That repeating sign means it goes on and on and on and on and on forever and ever and ever. It's still a rational number, but it's a different kind of decimal. So there's terminating decimals and there's repeating decimals. Okay. This is also going to be a repeating decimal, 4/9. Go to my calculator. 4/9 is 4 repeating. So again, -4 4/9 can be written as 4 4/10 repeating over and over. It means 4 is on and 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 on. And sevenths repeat differently too. You'll have seen this one in the activator, or the connect rather. 15 sevenths. It's going to repeat, but it's not one digit that repeats. It's actually 6. You'll notice it's 2 and this repeats. 1 4 2 8 5 7. 1 4 2 8 5 7. 1 4 2 8 5 7. So in this case, all that repeats. 1 4 2 8 5 7. I think it was 2 holes. So all this repeats over and over, but still a rational number because I can take this decimal can be written as that fraction. So even though the decimal repeats forever, still a rational number. So that's the first thing to know. Every rational number can either be written as a terminating decimal or a repeating decimal, one or the other. 2 types of decimals. If I reverse that, that means if you see a terminating or a repeating decimal, then it's a rational number. All terminating and repeating decimals are rational numbers. 12 5/10 is a rational number because I can rewrite it as 12 5/10, which I could rewrite as a fraction as 125/10. So when you use any terminating decimal, you can turn into a fraction, and so it is a rational number. Same with this one, -6 22/100. That's -6 22/100. We talked the other day about simplifying this fraction or finding the lowest possible equivalent one, which here I think if I divide by 2, I'll get it. And let's see, 6 times 50 would be 311/50. So when you see a terminating decimal, just know it's automatically a rational number. Because if you wanted to, you could turn it into a fraction. That's all it has to be rational. Repeating decimals are too, but they're a little harder to turn into decimals because when I do this, what's my numerator and what's my denominator? You know, is it this? Or is it this? Or is it this? I don't exactly know what to do because there's no clear denominator. So for the time being, I'm going to ask you to just take my word for it. We don't have the tools yet for me to show you how to turn this into a fraction, but it can be done. We need one more unit ahead of us before we're ready to do it. So even though you may not have it memorized, 3 repeating, that is a third. 2 repeating is 2/9. I just happen to know these because I've been around them for a long time. You'll start to have some decimals that you've memorized the fraction for. This one I don't. I made this one up. But take my word for it. When you see a repeating decimal, it can be written as a fraction. We just don't have the tools to do it yet. So when you see a terminating decimal or a repeating decimal, it is a rational number always. Okay? All right, open your notes. And we'll go back through those again with some we-dos for you. So let's start here. First thing I need you to know and write down, all rational numbers can either be shown as repeating decimals or terminating decimals, one or the other. So some terminating decimals. This is an easy one because we say this the same way we say the decimal. That's -2 8/10. So that's a terminating decimal. 5 and 11/20 is 5 and 11/20, 55/100. And negative 11/12 would also give me a terminating decimal. 11, again. 11/12. Oh, I was wrong. That's a repeating decimal, isn't it? It looks like it's not because they threw this 7 on here at the end, but a lot of calculators, what they'll do with a repeating decimal is they will round it at the end. So they're just rounding it to the 100th spot, but it's really 916 repeating. So I've got to put that way over there. My bad. That is negative 0.916, and just the line just goes over the 6. The whole thing doesn't repeat. You'll notice just the 6. All right, so we've got 2 terminating decimals. These will also be repeating decimals, 1 1/3. I think you know that decimal. That's 1 3 repeating. And sevenths will always, they'll always give you a repeating decimal too. 5 sevenths. Let's see, 714,285, 714,285, 714,285, 714,285, and that whole thing repeats. I'm going to put them on line for the whole thing. All right, so any fraction, when you do the math and change it to a decimal, it'll either be a terminating decimal or a repeating decimal, one or the other. They're both possibilities. And flip that around, all terminating decimals and repeating decimals are rational numbers too. So like I know this is a rational number because I can rewrite it as 3 and 25/100, which I can rewrite as 3 and 1/4 if I divide both by 25, which I can rewrite as, let's see, 4, 8, 12, 16, 17/4. So you can see that it's a rational number. And negative, let me do it down here. Negative 12 and 45/100. I think if I divided those both by 5, I'd get negative 12 and 9/20. And then I could turn this into a fraction too. Some number of 20ths. I don't want to do that math. So that means that's a rational number. If you can possibly write it as a fraction, it is. Repeating decimals. We do not have the tools yet to turn that into a fraction. I can't tell you what the denominator would be. You're just going to have to trust me till the next unit that if it's a repeating decimal, it can be a fraction. This one would be 5 2/3. 6 repeating is 5 2/3. And you may recognize this one, 12857. That is 1/7. So again, you can't do that yet. All I want you to know is repeating decimals are indeed possible to write as fractions, so they're both rational as well. Can be done. Okay, that's it, guys. 2 kinds of decimals, terminating and repeating. Both are rational numbers. That's it. If this was confusing, please go back and watch again so you're super prepared for tomorrow's class. Once you feel like you have a good handle on this, however, you're all set. Can't wait to see you in the morning.